The coordinates of the center of a circle and the length of its radius can be determined by just looking at the equation. There are two ways in writing the equation of a circle: the center radius form, or the standard form, and the general form. We are going to discuss first the center radius form. The equation of a circle centered at HK having a radius of length r is x minus h quantity squared plus y minus k quantity squared equals r squared. Now, these are the examples on how to express the equation of a circle in center radius form. The first one is we are going to write the center radius form of the equation of a circle with center at the origin and radius 8. Now, we all know that the coordinates of the origin are 0, 0. Now, let h be equal to 0, k equals to 0, and r equal to 8. Now, remember that the equation of the circle in center radius form is x minus h quantity squared plus y minus k quantity squared equals r squared. Now, let us substitute the given values. So, we have x minus 0 quantity squared plus y minus 0 quantity squared equals 8 squared. So, x minus 0 is x raised to 2 is equal to x squared. Then y minus 0 is y raised to 2 is equal to y squared. Then 8 squared is equal to 64 units. So this is the equation of the circle in center radius form. Now, if the center has, if the circle has its center at the origin, then you just need to square the length of the radius and then write x squared plus y squared. Now, let us go to the next example. Write the center radius form of the equation of a circle with center at 5, -2, and radius 4. Let us determine the given values. So we have h equals 5, k equals -2, and r equals 4. Now, the center radius form is x minus h quantity squared plus y minus k quantity squared equals r squared. So, let us substitute now the given values. So, we have x minus 5 quantity squared plus y minus -2 quantity squared equals 4 squared. Then, let us simplify 4 squared and minus -2. So, we have x minus 5 quantity squared plus minus -2 is equal to plus 2. So, y plus 2 squared equals 4 squared is equal to 16. So this is now the center radius form of the equation of a circle. It's very easy, right? Now let us proceed to the next example. In the next example, we are going to write the center radius form of the equation of a circle with center at 1, 4 and passes through the point 11, 8. Now we are not given the length of the radius. So this is the center and this is 11, 8. This is a point on the circle. So that means we can compute for the length of the radius using the distance formula. Now let us solve first for the length of the radius. So this will be our x sub 1, then 4 is y sub 1, 11 is x sub 2, 8 is y sub 2. So the radius of the circle is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Then let us substitute the given values. So we have the square root of 11 minus 1 quantity squared plus 8 minus 4 quantity squared. Then now we are going to simplify. So r is equal to the square root of 11 minus 1 is 10. So we have 10 squared plus 8 minus 4 is 4 squared. Then after that, we are going to square 10 and 4. So r is equal to 10 squared is 100 plus 4 squared is 16. So r is equal to the square root of 116. Now we are not going to get the square root of 116 because we are going to square the radius also. So let us write first r, the radius is the square root of 116. So let r be equal to the square root of 116. H is, these are the coordinates of the center. So we have 1 and then k is equal to 4. Now, let us now substitute the given values to our equation. The equation of the circle is x minus h quantity squared plus y minus k quantity squared equals r squared. So we have x minus 1 quantity squared plus y minus 4 quantity squared equals the square root of 116 quantity squared. So let us copy x minus 1 quantity squared plus y minus 4 quantity squared equals the square root of 116 raised to 2 is equal to 116 because we are going to cancel the radical sign and then the exponent. So we have here 116. Now this is the equation of the circle in center radius form.